Okay, so I got number 19 here, which may be the most difficult conceptual one yet. I'm going to move fast, but I'll be as clear as I can. Okay. We get a function, okay, which is the natural log of the absolute value of this. We want to know what the derivative is. Okay, here's how I attacked this. Okay. Absolute value. Well, let's think about it. If, and listen carefully, well, I'll write it down as well. If x squared minus 1 is positive, okay? Let's pretend x squared minus 1 is positive. Just think about that for a second. If that is the case, then the absolute value brackets do not matter at all. Because it's already positive, therefore the absolute value brackets aren't doing anything to it, okay? So if x squared minus 1 is greater than 0, if it's positive, that means that this whole thing is literally, it's just the natural log of x squared minus 1. The absolute value brackets do not matter at all, okay? But what happens if x squared minus 1 is negative? So if x squared minus 1 is negative, the absolute value brackets, what they're going to do is they're going to take that value and they're going to make it positive. So the absolute value brackets will take x squared minus 1 and take the opposite of it. So that means if x squared minus 1 is less than 0, this thing here actually becomes the natural log of the opposite of x squared minus 1. That's an important conceptual piece. Well, the opposite of x squared minus 1, just watch, is the natural log of negative x squared plus 1. Okay? So now, the way I thought about it, and I'll kind of sum up what I thought, is, okay, well, x squared minus 1 is greater than 0. Now, basically what I thought is x needs to be between negative 1 and 1 for it to be negative, but just drop that for a second. Watch. So the natural log of x squared minus 1 or the natural log of negative x squared plus 1. Those are the two functions to think about without the absolute value brackets. Okay. What's the derivative of this one here? The natural log of all of this. Well, we know the rule. It's 1 over x squared minus 1 times the derivative of the inside, so times 2x, which equals 2x over x squared minus 1. Okay? What about this situation? Well, it's 1 over negative x squared plus 1 times the derivative of the inside, which would be negative 2x. So this would be, I'm going to bring it down here, negative 2x all over, I'm going to say 1 minus x squared. Well, let's get rid of this negative sign. Multiply by negative 1, or negative 1, get rid of that negative sign. What you're going to get is 2x over x squared minus 1. I multiply the top and the bottom by negative 1. And look, here's the derivative if, in that case, here's the derivative in the other case, and they match. They're exactly the same. So actually, you probably didn't even need to do all that analysis, but I was just sort of proving it to you. So this has to be the derivative, and then, yep, there it is. Okay, it's D. You're done.